Today, we will review the dashboards that describe an observability demo application. These dashboards are using Vega components to emphasize the advanced capabilities that demonstrate how we can investigate different services behavior and how we can drill down, searching for root cause analysis in different scenarios. So first of all, let's discuss a bit what we are observing. OpenTelemetry is a specification and a set of framework and tools that help monitor and trace our application. This demo application describes an astronomy shop and allows user to simulate purchasing items This interaction is recorded in OpenSearch using the OTel collector and ingested into OpenSearch using data prepare. The first dashboard that we would like to see is the Observability Services dashboard. It shows all the services that we've seen earlier in the demo application and how they interact with one another as part of the purchasing process. This service graph is a Vega component and can be enhanced further using Vega language. Here we can see the breakdown of the services with respect to the interactions being recorded. We can filter selecting any service name or selecting specific response. We also have a list of the duration of the services, and we can see the ones that took most of the time. Next, we see the request rates versus duration graph, which is again the Vega component. This component is interactive and allows us to drill down and zoom in, viewing different types of behavior from different services. We can select, for example, a specific service by clicking the service name. This selection is being added to this filter chart. By clicking again, this would remove the filter, and we also have a list of service names marked in red, and by pressing them, this adds the error filter into the filter bar. So the services that has errors are shown. Now let's continue. Once we filtered all the services that had errors, we can now further drill down and select the most time-consuming traces. This table shows the traces after being filtered by the filter for errors within services. Let's select a specific trace. Selection of this trace shows a Gantt chart specifically for the trace and its spans. This is only a single span within the trace, but we can obviously remove the filters and begin again by not focusing on the errors, but rather selecting the highest duration trace and see where that leads us. This trace is decomposed of multiple services, and we can see that within this Gantt chart, the ones that take the longest period are related to the front-end service. So we have two ways of trying to analyze how our service is behaving. One begins with service response type, whether it's error or not, and the other one starts from the duration of the traces and then picking the services that has the longest durations. Now let's say that we are convinced that a specific service is the one that's causing duration issues for our customer. Next, we can select that service and click on that service. A new feature that will be added shortly will allow, after selecting the service by mouse clicking the name, to be landed on a single service dashboard with that service name selected in the filter, and this dashboard shows us all the metrics collected for that service and allows us to further investigate the behavior of that service in which we suspect that has anomalies. We can see here again rates versus duration chart. We can see all that service trace and spans, specifically how they behave within that service. We see in the case that this service is deployed within Kubernetes clusters, we see the composition of pods and their average daily error. And again, we can select a specific matrix and click the matrix name. This, once the feature is added, will land us within the matrix dashboard. This selection will also convey the context filters that we have already selected, so that that specific service and time range and other filters would be overlaid here as well. We are in the system metrics application performance monitoring, and we can see all the metrics related to the system: disk-based CPU, network, and so on. We have the capacity to filter them using devices, using read-write direction, state, and any other selection of dimension that we can add dynamically to that dashboard. Here we can see the system disk I/O samples, and we can go over and see the amount of samples for each sliding window. We can select read or write here to filter them down for that specific dimension. And the same goes for all of the additional metrics that collect information about the services, and specifically, once we select a service, that would filter only that service. Let's say it's a recommendation service. The effect would be as if we selected the recommendation service here. Now we see all the charts are changing only to show the recommendation service. So let's go back and review. We have started with the dashboard services that show all the services for a specific time range. We allow filtering for both time and service name and error type. And we allow filtering by traces, duration, and seeing the longest traces within the span chart. Once we have selected a service to further investigate and drill down, we select that service by pressing the network graph. That would land us, after the feature is complete, directly into that service dashboard, depicting the service within the selected context of the filter that we already pre-selected in the former dialog, and continuing filtering that service specification. And we can continue this effort by selecting a specific metrics collected for that service, and again it would lead us directly into that application performance monitoring metrics and allow us to further investigate and analyze what is happening within the system. This is all for today. Thank you, everyone.